Hi, my name's John Allen Pope. This is my technology lesson plan for IL 650. I developed this technology lesson plan with Mr. Lee Orr and Mr. Steve Simpson as an introductory lesson for quadratic functions in their pre-calculus classes. The goals of this lesson is basically to introduce the chapter of quadratic functions, making the transition from linear functions to quadratic. The goals of the lesson are for students to recognize and interpret graphs of quadratic functions, identify critical points of a quadratic graph, understand quadratic functions in real-world situations. Of course, we want these students to see where this math is relevant in the real world, and access their prior knowledge to make some predictions and solve some of these real-world problems. Okay, some of the key terms that students are going to focus on today are quadratic function, parabola, vertex, increasing and decreasing, and maximums and minimums. And we're going to talk about each one of those and try to get students using as many of those vocabulary words as possible as we introduce this. Okay? Okay, students, we have been dealing with linear functions and talking about lines of best fit. Of course, when we did linear functions, when we were drawing those best fit lines, the goal was to try to get as close to as many points as possible on the given graph. Of course, there may not necessarily be just one line of best fit, but as we, construct our line to touch or to go through as many points as possible, that would be one possible line of best fit. Okay. Now, using this picture of this student shooting a basketball here, what's wrong with our line of best fit? Correct. Yes, not every function is going to be a linear function. A linear function, remember, has the same pattern, and it's going to keep going up and up and up forever. Okay? Of course, we know something like a basketball is we're going to shoot the basketball at the hoop. It's going to go up, and it's going to come back down. Okay? So, this basketball model is definitely not a linear model. Okay? In fact, the basketball, like we said, when it goes up and comes back down, what shape does its graph have? It's like an upside down U, okay? Quadratic functions have U-shaped graphs, which are called parabolas, okay? What's making that basketball go up and come back down? Gravity, okay? We know that gravity, as we shoot it up, what goes up must come back down, okay? Now, what we're going to do in this lesson is just start off by using just our eyes, looking at these shots and making some predictions of whether or not we think when this student shoots the ball, whether or not it's going to go through the hoop, okay? So, let's look at this one. I'm going to play a little video. You're going to look at it and just see if you think it's going to go in the goal or not. Okay, I'll play it one more time. Okay, obviously they don't show us the ball going through the hoop. Again, we're going to make that prediction. Okay, now how can we use this picture of the balls going up to help us make a prediction? Okay, why did they stop the video at that point, at that precise point? Because that's the highest point of the basketball, okay? So, if that is the highest point of the basketball, what's going to happen after that point? It's going to start coming back down, isn't it? Okay? So what? The basketball has went from increasing all the way up to its highest point, and then it's going to start decreasing towards the goal, okay? So there's some of our good vocabulary words that we're going to be using as we go. Now, this highest point of a parabola is called the vertex. Okay, that is the point where the parabola stops increasing or decreasing and starts going the other way. Okay, So in this case, it would be the point where it stops increasing and starts decreasing, okay? Now, how can we use just that part of the graph, knowing that that's the highest point, to predict what it's going to do over here? Okay? Parabolas involve symmetry, okay? In fact, through that parabola, or through that vertex, there's what we call that axis of symmetry, okay? A line that divides it. So what? That half of the parabola is going to match the mirrored side of the parabola. So if we only know half of it, we really can predict what the other half is going to look like, okay? So again, all right, real quick, on your paper there, number 1, just write down whether or not you think it's going to go in the hoop or out, just by looking at it, and I'll play it one more time. Okay? All right, number 2, we're going to do it again. Let's predict this one, just using our eyes. Okay, he shoots the ball. Again, we're going to look at its highest point, and then you just make your prediction whether or not you think it's going to go in the hoop. Okay? Let's go to number 3. Okay, once again, just predicting using your eyesight. We see that part of the graph, we see the highest point. Let's make a prediction whether or not we think it's going to go in the hoop. Okay, number 4. Okay, play it one more time. Okay, again, he shoots it. We see it when it reaches its highest point. Do we believe the second half of the graph would make it go into the hoop? Again, look at your vertex up there. See where it goes from increasing to decreasing, what you predict. Okay? Let's predict number 5. Okay? That was a little more shallow of a shot, wasn't it? The last one was a really high arc. This one's a little shallower. Again, but what? It even shows us all of these parabolas can have different shapes, whether they're really steep or a little more shallow, but they all have that U shape. Okay? Going to number 6, make your prediction. There's one that's a little higher arc again. You shot that one underhand. But again, same shape. Make your prediction. Okay, so far we've just used our eyesight, just following the ball, just guessing from where we think the highest point's at there, just kind of visually in our mind making that second half of the graph. Okay, now as we go back through these pictures, we're going to use this interactive graph to transform the parabola to make our predictions and see how we feel about our first predictions, okay? So now, again, this is a parabola, but now if I drag this around, does this match my graph? No, okay? So again, quadratics, we know can either go up or the U can go down, okay? So again, we're just going to use those transformations like we've used in geometry and everywhere to move these graphs around, okay? So now, let's drag these. I'm going to put this dot at the highest point. Okay, what did we call that? The vertex. I'm going to drag this other dot to where he is releasing the basketball. That we know that is where he is releasing it. So again, notice we've got from our vertex, where he shoots it, to the highest point of our vertex. See how it's following? It's like a line of best fit. Okay? And then we talked about this half of the graph should match this half of the graph. Okay? So again, without saying anything out loud, just on your paper, make you a second column out beside it. And now, going back through, right next to shot 1, looking at this, using the model, do you think it's going in and out? In or out? Okay? Let's go to number 2. Again, I'm going to drag my vertex to my highest point, and I'm going to drag that point just to another point on the graph where he's releasing it from his hand. Okay? So now, again, follow this line of best fit here should match the second part of our graph. So again, make your prediction whether you think it's an in or out. Okay, number 3, I'm going to do the same thing. I'm going to drag to the vertex, and where he's letting it go, that gives us our line of best fit for the left half. And again, the left half of the parabola should match the right half through that axis of symmetry. Okay, there's an imaginary line coming right through here, through the vertex, straight down, and we've got mirror images. Okay, predict whether you think that one's in or out. Okay, number 4. Again, this was one of the ones that was a little higher arc. So you can see when we drag these points, our parabola is a little steeper. Okay, but it goes up, and what goes up must come down. So predict in or out. Number 5, a little more shallow than the last. So you can see our parabola is a little wider again. So make your prediction, in or out. Number 6, I'm just going to keep doing the same thing. Dragging it, matching up the left half, line of best fit. Now make your prediction for the right half. And last, number 7. If I drag those points again, he let it go a little bit lower, but still, if I match my highest point and where he's releasing it, I've got a line of best fit for this side, and I can predict the right side. Okay? Okay, so now you've got all of your predictions. Okay? Take a look in your groups. Take a look at, well, let's start first. Take a look at your predictions. Did you feel more confident in your first set of predictions than in your second set of predictions where we actually drug the points around the graph? Okay? And then compare your answers in your group. Just take a quick minute here and compare your predictions in your group. Okay? How many people thought it was easier for the first predictions where we were just using our eyes? Okay, how many people thought actually dragging the points around? Okay? Yeah, the majority of us are probably choosing these parabolas because we're getting that actual visual of we see this line of best fit on the left side and we see the actual graph for the right. Okay? Okay, let's verify our answers right here. So number 1, it went in. It went in. See how once it reached its highest point it matched and it did go through the hoop. So just see how many of these we got right. Number 2, it did not go through the hoop. It was too wide. It hit the back of the rim. Number 3, it did go through the hoop. Number 4, too short. It did not go through the hoop. Number 5, it did go through the hoop, but we didn't necessarily know it was going to go through the hoop because of what? It was actually too wide, but he did catch the backboard, so it banked in. So that was a little tricky. Number 5, you can see that bank again, a little tricky. So that probably got some of you. Number 6, did not. So again, this time it was a little too wide, but it didn't get high enough on the backboard to bank in. It hit the back of the rim. Okay, number 7, it did go through the hoop. Okay, so take a look at those. Okay, just kind of see how you did right there. Take a quick minute, see how you did. Did anybody get them all correct? You know, see if anybody did. You'd have had to get that bank shot if you did. Okay, so again, we're just starting our quadratics unit today. Okay, these were just some introductory problems just to look back at the graphs. We see the kind of shape, use some of those vocabulary. Okay, so for your assignment right now, your writing assignment in your journal, I want you to reflect on what you learned about quadratics using as many vocabulary words as possible. Okay? So again, as we go back and look at those vocabulary words, talk about how we were using those graphs in that situation with shooting the basketball, and use as many of these key terms as you can. Okay? And then, once you've talked about those, I want you to list at least 3 other real-world examples or situations that you believe would be appear to be quadratic. Okay? So again, what shape would they need to have? The U shape. And it could either be going like that or an upside down U. Okay? So again, list at least 3 other real-world situations or examples that you can picture that would be quadratic when they appear. Okay? And we'll talk about all of this in just a little bit. Okay? Thank you.